Great, so here we go with the homework this week on trigonometry. The angles alpha and beta are such that tan alpha is m plus 2 and tan beta is m, where m is a constant. Given that this is true, find the value of m. So we've got to kind of got to link these things together, haven't we? We've got sec squared and we've got tan. Aha! We know our identities that we've got on our poster and we've memorised and we chant to ourselves as we walk down the street. We've got things like, well, we know that sine squared alpha plus cos squared alpha is always 1, so if we divide that through by cos squared, we've got tan squared alpha plus 1 is sec squared alpha. Okay, so sec squared alpha there is equal to tan squared alpha plus 1, so that's equal to m plus 2 squared, and 1 is, oh, sec squared alpha, there we've got rather too many signs going on. Okay, so if we rearrange this, then what we're going to say is that sec squared alpha is, do we need to multiply it all out? Probably. M squared plus 4m plus 4 plus another 1. That's what sec squared alpha is. Are you alright, you two?
Yeah, we're fine.
That's good. So we've got sec squared alpha is m squared plus 4m plus 5. At the same time, we've got sec squared beta is also equal to tan squared beta plus 1. So that is m squared plus 1. Okay. If we put this together, these two things combine to give 16. So therefore, m squared plus 4m plus 5, take away m squared plus 1 is 16. We're heading to, we're not even heading to a quadratic, are we? We're heading to 4m plus 4 equals 16, which would suggest that 4m is 12. M equals 3. There we go. And we've got our first 3 marks of the day. Very exciting. Hence, find the exact value of tan alpha plus beta. Well, we know, actually we know this from our formula booklet, that the tan of alpha plus beta, straight out the formula booklet, that is tan alpha plus tan beta over 1 minus tan alpha tan beta. And we've got these things in terms of m up there, haven't we? So tan alpha is m plus 2. Tan beta is m. On the bottom line, extra brackets or little place, we've got m plus 2 times m. And so we don't really need it in terms of m, but I'm doing it in terms of m. We've got there 1 minus, I don't know why I'm multiplying this all out, m squared plus 2m, I'm sorry. M is 3, that's the key to all of this, isn't it? M equals 3, so therefore this is 6 plus 2, and here we've got 1 minus 9 plus 6, 8 over minus something, 14. So tan alpha plus beta is minus 4 over 7. And there we go. Collect another 3 marks, put them in our rucksack, and hike home. That's a good 6 marks. Excellent. On to question 2. Now, this is where it got interesting. By first writing sine 3 theta, sine 2 theta plus theta show that this stuff is true. So, sine 3 theta is sine 2 theta plus theta. That's very interesting. And then, using our identity that appears in the formula booklet, sine A plus B, that's sine 2 theta cos theta plus cos 2 theta sine theta. We've got that. We're looking for something that's just in terms of theta. So we're going to have to get rid of the 2 thetas and things like that. So sine 2 theta, again, think that the identities that we go through, if we've got the sine A plus B, we make A and B the same, we get sine 2A, which is 2 sine A cos A, so 2 sine theta cos theta times cos theta. We want to end up with this all in terms of sine. So this cos 2 theta here, we're going to use the identity that allows us to rearrange that. Now remember, cos 2 theta is cos squared minus sine squared, which makes it 1 minus 2 sine squared times sine theta. We've got 2 sine theta cos squared theta, and here we've got sine theta minus 2 sine cubed theta. And we're going to use another of our identities, but this comes from core 2, doesn't it? Cos squared is 1 minus sine squared, so 2 sine theta, 1 minus sine squared theta, plus sine theta minus 2 sine cubed theta. We're nearly there. We've got 2 sine theta, take away 2 sine cubed theta, plus another sine theta, take away 2 sine cubed theta, and if we collect together like terms, we have 3 lots of sine theta there and there, take away 4 sine cubed theta, which was what we were heading towards. Brilliant, as required. Okay, the question then said, where is it? Determine the greatest possible value of this 9 sine 10 over 3 alpha minus 12 sine cubed 10 over 3 alpha, and find the smallest possible value of alpha in degrees for which that greatest value occurs. Okay? We need to compare this with what we started with. So this is, we've got a common factor here of 3, so this is the same as 3 lots of 3 sine 10 over 3 alpha minus 4 sine cubed 10 over 3 alpha. Okay, and remember that the question came into this with this being sine 3 theta. This was sine 3 theta, so in that case, what we're going to say is this lot here is the same as 3 times sine 3 lots of this angle. And 3 lots of that angle would be 10 alpha, wouldn't it? So this we could just write as 3 sine 10 alpha. Hence find, it says, the smallest possible value of alpha, the greatest possible value of this. Well if sine theta, sine alpha, goes up to plus 1 and down to minus 1. So 3 sine that would go between plus 3 and minus 3. So the greatest value would be 3. And hence find the smallest value of alpha for which that occurs. Well, that would occur if we think about our sine graph. The sine graph is doing this, isn't it? And the first value occurs in degrees, occurs at 90 degrees. So that biggest value occurs when 10 alpha is equal to 90 degrees. Which means that alpha equals 9 degrees, and that would be our right answer there. We've had a little discussion already about what smallest means, and when we talk about an angle, it should be fairly obvious that when we're talking about an angle, smallest means closest to 0, doesn't it? Don't shake your head.
What do you think?
Still shaking your head. Michael's suggesting it means the most negative, so the smallest one would be the closest to minus infinity. I know. Yeah, Sam is exactly right. His son's going. There we go. Right. Part 3. It's all right. I mean, that little discussion was on the video, but it doesn't matter because nobody knows which Michael we're talking about, or which Sam. Sam's not bothered. Part 3. Solve for beta between 0 and 90. The equation 3 sine 6 beta cosec 2 beta equals 4. Now that looks like a horrific monster. It's 6 marks. If you come into that without having done anything else, then you've got some work to do to solve that. But this is a part 3 of a 3-part question, and it's labelled parts 1, 2 and 3, not A, B and C. So that's a suggestion that it all links together somehow. So we're going to have to try and link this together somehow and see what can be done. Well, what can we do with this? We can start by recognising that what we've got here is, I'm writing it again. Oh yeah, let's do it like this first. That is 1 over sine 2 beta. I think that's the sensible place to begin with this. So we start by recognising that the process is 1 over sine. Now here we've got 3 sine 6 beta, and going back to our identity, it says that 3 sine 3 theta is equal to that one. So if we replace theta with 2 beta, then we're looking at sine 6 beta, aren't we? And that would be 3 lots of, and this is going to be 3 sine 2 beta. Where are we going with this? 3 sine 2 beta minus 4 sine cubed 2 beta over sine 2 beta equals 4. And so we can factorise what we've got here. We've got 3 lots of sine 2 beta times 3 minus 4 sine squared 2 beta over sine 2 beta equals 4. Our sine 2 beta is going to cancel out. Are we alright here? Are we all still together with this? If we rearrange what we've got, then we've now got, what's the easiest way of doing this? 9 minus 12 sine squared 2 beta equals 4. So shift things around a little bit. We've got 5 is 12 sine squared 2 beta. So sine squared 2 beta is 5/12. 2, thank you. Thanks, Darren. So sine 2 beta is plus or minus the square root of 5/12. So now we need to use our calculator and do inverse sine of that and come up with some angles. I'm going to the pleasantly cheap Aurora AX59 5TV, and I'm doing, I know, inverse sine of, let's do the positive one, and the calculator says 40.2 for that positive square root. So the cast diagram, there it is, we love the cast diagram. Cheese and slimy toast, and that gives us 40.2 there, and 40.2 there. I don't know. And so the next value that we'd be looking at would be 139.8. Is that right? if we take the negative square root, then the negative square root is going to give us values that are outside the range, isn't it? It's going to give us minus 14.2, and the other value would be minus 139.8. We're only considering values in the range 0 to 90, so we don't need to worry ourselves about these at all. So we're dealing with these two. The last thing to do is to divide by 2. So beta equals, I'm going to say 20.1, using the power of my head to divide that. Special. And the other one, I've used a calculator, I'm embarrassed. I come up with 69.9 degrees for that. 3 something figures. And we've got these two answers. Are we happy with these? I think somewhere I've got the marks to give. Here's this one. There we go. So we've got our 6 marks for working our way through that. Getting to sine 2 beta is square root of 5 over 12. It's 4 marks to get to that point.
Got 11.
There we go. Good. Right.
I still don't really quite get how you talk about it now.
Right, that what? All that was happening there was I spotted that sine 6 beta, well, the first part of the question told us what sine 3 theta was. And that's similar to sine 6 beta. That's like having sine 3 times 2 beta. That's sine 6 beta.
Okay.
So instead of theta, we use 2 beta. So 3 sine 2 beta minus 4 sine 2 beta.
Okay, I get that.
That was my substitution. That sorted it. Okay? There's one bit here that in doing this, we do also get a situation where we could be saying that sine 2 beta is a factor of what we end up with. But of course, as a solution of this equation, sine 2 beta can't be 0 because cos 2 beta doesn't have a value at that point. So that value is not defined within that range. So we don't need to worry about that. Right. We need to stop the video and we need to say, and that's maths.